See here, in this session we are going to be discussing about of the photo cells. Actually this is called as one of the photoelectric cells. We are going to be calling this one as one of the photo cells. Okay. See in this one, what do you mean by of this a photo cell? Here we are having the definition, that is it is a device which is going to be converting the light energy into the electrical energy. Okay, right. In this one, where is the light energy actually? See here, the light energy is going to be incidenting on this plate. After this one, photoelectric effect is going to be happening. Due to the photoelectric effect, electrons are going to be producing. These produced electrons are going to be travels towards of the another electrode. Okay, right. So whenever these electrons are going to be traveling from one terminal to the another terminal, one electrode to the another electrode, then automatically this is called as one of the current is going to be flowing. So this light energy is going to be converting into the electrical energy. Right. This light energy converts into the electrical energy. This device is known as the photo cell. Okay, right. Now we are going to be discussing about of the construction of this photo cell. Okay. See here we are having, this is one of the cathode plate and this is one of the anode. Okay, and this cathode is having one of the semi-cylindrical material. Here we are having one of the semi-cylindrical material, and here we are having of one wire loop. This wire loop is going to be act as one of the anode, and this semi-cylindrical plate is going to be acting as one of the cathode. Whenever this light is going to be incidenting on this photo cell, then photoelectric effect is going to be happen. So it is going to be producing the electrons. In another way, this is also called as the emitter. This emitter is going to be producing the electrons as well as emits the electrons, and this anode, otherwise this wire loop is going to be collecting the electrons. So that's why this is called as one of the collector. Okay, right. Now see here, this plate and this loop are going to be connected to one of the high tension battery. Okay, right. Electrons are going to be producing, electric field also going to be producing. Due to the electric field, current is going to be producing. So this is called as one of the photoelectric current. Okay, right. And whatever the current produced in this one, that is measured with one of the ammeter. Okay, and the current range will be in the form of 10 to the power of minus 6. 10 to the power of minus 6 means micro. So that's why here we are using one of the micro ammeter. Right. And next case, this whole arrangement is placed into one of the evacuated glass bulb, otherwise evacuated quartz bulb. This is the total construction about of the photo cells. Okay, right. Yeah, once again I am repeating the definition of this photo cell. Photo cell is a device which converts the light energy into the electric energy. Okay, right. Now coming to this one. What are the uses of this photo cells? Okay, these photo cells are going to be using in photographic cameras. Okay, right. And what is the use of this photographic cameras means, by using this photographic cameras we can measure the intensity of light. Okay, for example, in summer case we are having the more intensity of light. Okay, in rainy season we are getting the some less amount of the intensity of the light. So we are going to be finding the intensity of the light, that is called as one of the photographic cameras. As well as we can use of these photo cells in case of the cinematography also. Okay, right. Now coming to this one, another case. Here these photo cells are going to be used in street electric circuits, that is automatic on and off the lights. For example, we are having 1 kilometer, 2 kilometer, 5 kilometer length is some road is there. Otherwise, we are living in one city or one town, otherwise one village. Regularly, at the time of evening, we have to be switch on the lights, as well as in the morning session, we have to be switch off the lights. Regularly, it is not possible. Okay. So, that is why depending upon the intensity of this sunlight, intensity of the light, we are going to be automatic on and offing the lights. That is called one of the street electric circuits also we are going to be using of this one. And next case, traffic defaulters. Okay, for example, red light is on, so we have to be stop it there. Green light is on, we have to be move. And some people are going to be move in case of a red signal also. At that time, who are going to be jumping the signals, who are going to be crossing the laws of the traffic rules. Okay, immediately we are going to be catching them by using of this photo cells. That is called as one of the traffic defaulters we are going to be finding. And the next case, we are having another case, that is the automatic counting machines. For example, some function is going on in some auditorium. How many members are entering into the auditorium and how many members are leaving from the auditorium? And at present, how many members are present in the auditorium? That is also going to be counting by this photo cells itself only. Okay. So, this will be the total information about of this photo cells. Right. Yeah. Coming to the next topic, that is of our de Broglie hypothesis. Okay. Right. Yeah. In this de Broglie hypothesis, what he explained, first of all, he explained about of the wavelength of the radiation. Okay. Right. And what are the main sources for this de Broglie hypothesis means, see here, already we have discussed about of this photoelectric effect and Compton effect also. In this photoelectric effect as well as in this Compton effect, both are explaining that this radiation, incident radiation, light, okay, is one of the particle. Light is one of the particle, otherwise that radiation is treated as one of the particle, otherwise that radiation behaves as one of the particle. Okay. This is the first case of the radiation. Consider this is the first case of the radiation. And second case, coming to the second case. In case of interference pattern as well as a diffraction also. Okay, we have discussed about of this one also in case of the light units. Okay, there. In this interference and this diffraction pattern cases, this radiation, it means this is one of the light wave. This radiation behaves as one of the wave. Okay, it means this radiation, otherwise this light behaves as particle as well as one of the wave also. It depends upon the situation. Okay, how the situation is going to be demanding and how this radiation is going to be behaving as particle as well as the wave. Okay, now let us take a look on this one. This is one of the single radiation and here we are having of this particle. This is the first case. Here we are having, this is the wave, it is the second case. When this radiation is going to be behaving as a particle, it means whenever this radiation is going to be deals with some matter. Okay, for example, it is going to be incidenting on some obstacle, then the light is going to be, going to be, yeah, right. See, this radiation is going to be behaving as two ways depending upon the situation. That is, one is the particle and second thing is the wave. Right. When this radiation is going to be deals with the matter, then this radiation behaves as a particle and this radiation is going to be propagating, moving in the forward direction in a medium. Then this radiation is going to be behaving as a wave. See this one, interference pattern, all are the propagating cases only. And here it is the photoelectric effect. This is going to be dealing with some matter, it is going to be incidenting on that one, then the light is going to be becomes as one of the particle case. Okay, so in this way this radiation is going to be behaves as one nature is particle and second nature is the wave. Okay, right. Now here we are having of one equation for the de Broglie wavelength. Okay, this radiation, it is moving it like this. So from here to here, it is treated as one of the wavelength, that is called as the lambda. So for this wavelength, de Broglie has given one equation for the de Broglie wavelength, that is the lambda is equal to h is divided by of p. H is known as one of the Planck's constant, that is h is equal to 6.625 into 10 to the power of minus 34 joule into seconds. Already we know about of this one. And p is the momentum of a particle. Then if you are going to be talking about a purely one of the particle, then it will be becomes as one of the p is equal to m into v. Okay, right. Now we are going to be discussing about of this one in case of the light particles itself only. Then p is equal to mc also we can write. Don't forget here, we can write this value as mc also, p is equal to mc. Okay, velocity of the particle, velocity of the light particles. Right. Now, and see one more case here, we are having some concepts, just I would like to recall of all these things, that is, we are having a relation between the kinetic energy to the linear momentum, that is kinetic energy is equal to p square is divided by of 2m. So p square is equal to 2m into kinetic energy. Okay, right. And in case of the photoelectric effect, Einstein's explanation, we know that this kinetic energy is equal to the stopping potential. Okay, right. So now this momentum equation I am going to be writing, removing of this square, so taking the under root at this place. So p is equal to under root of 2m into kinetic energy. In other words, p is equals to under the root of 2m into E into U, electron volt. Okay, right. Now just the same case, we are going to be substituting of this p value in this de Broglie wavelength equation only, that is lambda is equal to h is divided by p we are having of this equation at this place. So 2m into ke, and ke is equal to this equation, that lambda is equal to h is divided by under root of 2m into electron volt. Okay, right. And we know the value of this one. And the next case, see here, now we are going to be giving the total value. Now I am going to be giving you the total value for this one, that is especially in case of the electron. Okay, that is, what is the mass of the electron? That is 9.1 into 10 to the power of minus 31 kg. And the charge of the electron, this is one of the charge of the electron, that is E is equals to 1.6 into 10 to the power of minus 19 coulombs. Already we know all these values. Now substitute this mass of the electron as well as charge of the electron as well as this Planck's constant in this equation, that is lambda is equal to h is divided by 2m into eV. Okay, that is 6.625 into 10 to the power of minus 34, 2 into 9.1 into 10 to the power of minus 31 kg and 1.6 into 10 to the power of minus 19 coulombs. And this is the potential difference between the anode and the cathode. Okay. So if we are going to be substitute all the values in that equation, then we are going to be getting up this equation, simplified equation directly I am writing, that is the lambda is equals to under the root of 150 is divided by of a potential difference. Why we are not giving up this one means for different materials different potential values we are having. So that's why this is one of the variable and all are having some constant values only. Okay. If you wanted to be simplify further case, then it will be 12.27 is divided by under the root of V angstroms. Okay, wavelength always we are going to be taking in the form of the angstroms itself only. Otherwise, we know the value of this angstrom, that is the angstrom is equal to 10 to the power of minus 10 meters. Okay. Yeah, right. Now coming to the de Broglie hypothesis. He said about of the three cases, that is the universe consists of matter and radiation. It means the total universe is having the matter, at the same time it is having the radiation also. Okay, right. And coming to the second case, that is the nature loves symmetry. Wherever you go, it is having all total case, we are having the same symmetry case itself only. It means simply in our understanding manner, wherever you go, that becomes as one of your friend itself only. It becomes as one of the similar cases, symmetry. Okay, that is the another case, nature loves symmetry. Okay, and the third one, that is if this matter is going to be behaving as particle as well as the wave. Okay, just now only we have discussed about of these cases. This matter is going to be behaves as one of the particle, otherwise the wave. Then this radiation is also going to be behaves as one of the particle as well as the wave, particle and the wave. Okay, so these 3 points are the hypothesis of this de Broglie. Okay. Yeah, right. Yeah, here we are having the next concept, that is the Heisenberg's uncertainty principle. Yeah, in case of the IP, this Heisenberg uncertainty, this comes for 2 marks. Only 2 marks question is there. And in case of the exactly IP, just we have to write off this statement afterwards. This equation is enough. If you want to write the total story means, okay, fine, no problem, but up to here it is enough. Why? Because in IP case they are going to be asking about of the statement of the Heisenberg uncertainty principle only, right? Now we will go for the statement for this Heisenberg's uncertainty principle. It is impossible to measure simultaneously both. First one is position of the particle and second thing is momentum of the particle. Which type of particle? Microscopic particle. Micro means 10 to the power of -6, a minute particle. Okay, right, in our understanding manner. Yeah, coming to this one. Let us consider this particle is moving in the form of the wave. If you are going to be identifying exactly at this place, at this location, I wanted to be find. So I got the position. Whenever we are talking about of the position, then the momentum is missing. Momentum, what is the value of the momentum? P is equals to m into v. Mass is there and velocity becomes as 0. Okay, so mass we are getting and velocity is 0. So total 0 into something is equals to 0. So momentum is going to be missing. If we are going to be finding the momentum, it means we are calculating the velocity. Then what happened? This position is going to be missing. Okay, right. The same case, both one is the momentum and second thing is the position of the particle. We can identify only any one of these two. If we wanted to be find the position, then momentum is going to be missing. If we wanted to be find the momentum, then this position is going to be missing. This is explained by Heisenberg. So this is called as one of the Heisenberg uncertainty. There is no certainty between the position as well as the momentum. That's why it is called as one of the uncertainty imbalancing cases. Okay, right. For that one, here we are having up some equation for the Heisenberg's uncertainty principle. That is the delta x dot of delta p is less than or is equals to h cut. And what do you mean by of this h cut value? Means h is divided by of 2 pi. In some books you may find it is the value of 2n pi. N is equals to 1, 2, 4, 6, like that we are going to be getting. That is h by of 2 pi, h by of 4 pi and so on, like that we can get. Okay, right. If you are going to be substituting of this value in this equation, that the value of delta x dot of delta p is less than or is equal to h is divided by of 2 pi. Okay, right. Now further if you wanted to be discuss about of this one, that is the I am talking about of the position, exactly the position. Okay, then delta x means change in the position. So delta x change in the position will be 0. Then automatically this change in the momentum it becomes as infinity. How it is going to be become as one of the infinity case? Yeah, just we will take a look on this one. In another case, delta p change in the momentum. It means we are going to be finding the momentum. Okay, we are going to be stopping at some momentum. So change in the momentum it becomes as 0. Then automatically this delta x change in the position becomes as the infinity case. How it is going to be becoming? Yeah, now we will take a look on this one. This is the value of delta x into delta p is equal to h. I am taking off this value with taking the equal case itself only. It becomes as 0, right? So I am taking it is the value of 0 into delta p is equal to h cut. Okay. Now we need the value of delta p itself only. So it is the value of delta p is equal to h cut is 0 by of h cut is divided by of 0. So something by 0 it becomes as infinity. Is that clear? Here also in the same way, that is delta p dot of delta x is equal to h cut I am taking, and it becomes as the 0 into delta x is equal to h cut. So, delta x is equal to h cut, it is divided by of 0, it becomes as 0, the same case.